Okay, welcome class. Here we are. We're recording. We're on section 4.1. We're recording. We're live. Yeah. Okay, so we're talking about 4.1 and interpreting graphs. And on this graph, on the bottom axis, you have the price of a haircut. And on the y-axis, you have the number of customers that they have. So my first question is, which one of these quantities would be the independent or the control? Actually, let's go ahead and write that down next to independent. Another word that we often use is the control variable. Which one of these quantities would be in control? The price or the customers? Price is not revenue. Price is not how much money they're making. Price is like the sign on the door. Hey, haircuts, $10. Haircuts, $20. So what do you think's in control? The price. And what happens as the price goes up? As the price goes up, number of customers goes down. Okay? What do you think is true about that price of that haircut right there? Right there? This one right there at the axis. That price is what? Okay, so at this amount, let's say that this salon says, hey, haircuts, $120. Woohoo! $121. That price right there would be so high. How high is it? It's so high. How many customers come? None. They priced everybody out of the market. What is that called? X-intercept, Y-intercept. That'd be called the x-intercept. You know another word for it? The horizontal intercept. A little fancier, all right? So that's the x or the horizontal intercept. The independent variable here is definitely the price. Dependent would be the number of customers. The independent or control variable will always be on the x-axis, while the dependent will always be on the y-axis. Got it? I'm not sure why the paper says real-world meaning. I think I put that there just to make sure we discuss the real-world meaning of the graph. I think we already did. We talked about the real-world meaning of this. What's the real-world meaning of this point? That y-intercept was what? Free haircuts. Yay! $0. And that's the maximum number of customers they had, right? That's how many customers they would have if the haircuts were free. Got it? So that's our basic interpretation of a graph and how, as you're going along the x-axis, something else is happening on the y-axis. Could you describe this change as increasing or decreasing? Definitely decreasing. Is its rate of change constant, increasing, or decreasing? The rate at which it's changing. Question 1, is this a straight line? Is this a linear graph? If it's linear, then that change is what kind of change? Someone said it. It's a constant type of change. If it was increasing more and more rapidly, it would look like this. Sorry, decreasing. If it was decreasing more and more rapidly, it would do this. Okay, that would be decreasing at a faster and faster rate. See how the drop-off is getting faster? Is this still decreasing? But what's happening to the rate at which it's decreasing? It's slowing down. Okay? Describe this graph. Hurry before it disappears. Wait, let's do that again so it doesn't disappear. Okay, back to you. What's happening in the star portion? It's increasing at a steady rate. Good. What's happening in the smiley portion? Changing rate. Faster and faster changing or slower and slower? Faster and faster. What happens when it transitions from smiley to flower? Okay, it levels off and stops increasing. That's called constant. Was it a sudden change or gradual right there? It was a sudden change. Any pointy part or corner in the graph would be a sudden change in rate. Okay?